guys, you're welcome to Prepclass Tutors, and with you is Mr. Chima. As you can see, we will continue with our WAEC past question papers on chemistry for the year 2020. So guys, what's good, what's popping, what's chilling? How do you see our videos? How has it been helpful? Hope our videos has been very helpful in helping you to answer all those questions that seem a bit difficult, but they actually are not. Hope our calculation aspect have been very engaging, and it has helped you to blast all those calculations which you might find a bit challenging. Please, Prepclass, we always like you to subscribe to our YouTube channel, like our YouTube channel, and do not forget to drop your comments on our comment section box so that we can know how our videos has been very helpful and engaging, and or how we can come maybe to your aid if you need maybe special assistance on a particular subject. Now, do you know that there are some students that are missing out of this great opportunity that you are enjoying here? Yes, there are many students that may not know about this. Please, so we would like you to always try and share our videos, so that just like the way you are benefiting from this, other students like you that also have one or two problems, or even have much more challenging problems than you are, can also benefit. So Prepclass would like you to always like our YouTube channel, drop a comment on our comment section box on what you think about our videos, and always try to share our videos so that they can reach as much students as possible within the globe. Okay, so today let us go straight to the point. Now, in our previous videos, we have attempted, or we have completely solved questions number 1 to 40, I believe so. Yes, questions number 1 to 40. So today, Mr. Chima is going to be engaging you on this same past question, WAEC chemistry for 2020. But today we'll be looking at questions 41 to 45. So quickly, without wasting much of the time, let us go. Question number 41 says, which of the following arrangement of elements is in decreasing order of electronegativity? Which of the following arrangement of elements is in decreasing order of electronegativity? You can see their arrangement. Now look at what I did here. First of all, I defined electronegativity for you. So as you can see here, I first of all defined electronegativity for you. I said that electronegativity is the power of an atom of an element to attract electrons. The power of an atom of an element to attract electrons is known as what? Electronegativity. Now you must know that electronegativity increases across the period from left to right of the periodic table. Why? Because in the first group 1, 2, 3 of the periodic table are usually metals. Are you following? Metals will not have power to attract electrons because they can easily donate electrons. So because of that, as the reactivity of the elements decreases in terms of electropositivity, electronegativity will increase. Elements in group 1 are the most reactive metals. They are more reactive than those in group 2. Group 1, 2, 3 are metals, but group 1 are more reactive, then group 2, followed by group 2, then followed by group 3. Group 4 are mostly those metals that are combined by sharing electrons. Then from group 5 to group 7 are the non-metals. So you can see that across the period, electronegativity will increase because there is decreasing electropositivity. Therefore, there will be what? Increasing electronegativity. So I believe you understand me now. So across the period, there is what? Increasing electronegativity because there will be what? Decreasing electropositivity. Then if you go backward and say phosphorus, silicon, aluminium, magnesium, and sodium, it means that electronegativity is what? Decreasing. But forwardly, it is what? Increasing. Backwardly, it is decreasing. Now they ask you the order of decreasing electronegativity. So your correct choice or way should be phosphorus, silicon, aluminium, magnesium, sodium. Phosphorus, silicon, aluminium, magnesium, sodium. This shows what? Decreasing electronegativity. And because of that, your best choice is what? D. Phosphorus, silicon, aluminium, magnesium, and sodium. I believe you understand this, eh? Good. Now, question number 42. The metallic bond in magnesium is stronger than that in calcium because magnesium has the metallic bond in magnesium is stronger than that in calcium because magnesium has, is it a large atomic size? Is it a small atomic size? Is it a greater number of valency electrons? Is it a lower melting point? Now look at what I said here. I said that magnesium atoms have a smaller atomic radius than those of the calcium. Yes, magnesium has a smaller atomic radius than that of the calcium. Now, because of this, the electrons are closer to the nucleus. Because when an atom has a small atomic radius, you know, if I draw a circle now, from the center of the circle to the circumference is what? The radius. So if an atom has a smaller atomic radius, that means that the shell will be smaller. And because the shell is smaller, it will make the electrons, remember that atoms are in the center, which is the nucleus. Electrons revolve in shell. So now because the atom as a whole is smaller due to smaller radius, it will make what? The electrons that are in shell to become closer to the center where the nucleus is. So if the electrons are closer to the center where the nucleus is, the electrons will have, there will be a strong electrostatic force of attraction between the protons in the nucleus and the electrons. You can see. So that was why I say that because of this, the electrons are closer to the nucleus, making the electrostatic force of attraction between the nucleus and the electrons stronger, resulting in a stronger metallic bond. So because the atomic radii is small, making the electrons in the orbit closer to the center where the nucleus is, the electrons are negatively charged. In the nucleus, we have the protons and the neutrons. The protons are positively charged. So the protons will become attracted, holding the electrons more. It will be attracted to the electrons, creating a strong electrostatic force of attraction. That will make the metallic bond of that atom to be stronger. Now, you must understand that the small atomic radius translates to small atomic size. If a circle has a small radius, the circle will be small. So small atomic radius means small atomic size. So because of that, the best answer is smaller atomic size. So I believe you understand why it is smaller atomic size. All right. So quickly, question number 43. Consider the reaction represented by the following equation. So the reaction says AgNO3 aqueous. This should be AQ. They made a mistake. AQ aqueous plus NaCl aqueous will give you AgCl solid and NaNO3 aqueous. Now the steps that could be taken to obtain pure dry sample of AgCl from the mixture includes, they are asking you, after you've reacted AgNO3, that is silver triazonitrate 5 with sodium chloride to give silver chloride and NaNO3 sodium triazonitrate 5, what steps will be taken in order to get a pure dry sample of AgCl2 or AgCl rather? What steps will be taken to get a pure dry sample of the AgCl? That's this one, which is silver chloride. Is it heating to saturation and drying? Is it filtering, evaporation and dryness? Is it filtering, washing and drying? Is it crystallizing and allowing to cool? Now, if you look at this reaction, you see that this solid means that this AgCl will be formed as a white precipitate. It will form as a precipitate. If you've performed the reaction before, this AgCl is insoluble. It will become a white insoluble precipitate. Are you following? So because it is a white insoluble precipitate, it simply means that it is not soluble in this solution. Therefore, it will also not be soluble in water. So what you do is that after mixing these two to get this white precipitate and this, the first thing you have to do is to filter it. Since this one is insoluble, if you filter that mixture, this AgCl will stay on the filter paper. When it stays on the filter paper, you can use water. Since it is insoluble in water, you can add some quantity of water and spill it on that filter paper where this AgCl is to wash it. to remove every drop of any nutrient. So one is filtration, the second one is washing. So you just pour small water inside there to rinse it very well so that you have this clean HCl on the filter paper. And what's the next thing you do? Of course, the next thing you do is you put it close to the window so that it will dry. So which of these options now best illustrate my answer? Filtering, washing, and drying. And that would be the best process because it is insoluble. So you have to filter. Since the same is insoluble, you can wash it to make it clean. Then after that one, you now expose the filter paper to air for it to dry. It's as simple as that. So that is why C is your best choice or your best answer. Question number 44. How many electrons does P3 minus contain? How many electrons does this contain? Is it 12? Is it 15? Is it 16? Is it 18? How many electrons does P3 minus contain? Now if you look at this very well, you see that this P3 minus is an ion. This 31 is the mass number, which is the number of protons and neutrons. This 15 is the atomic number, which is the number of protons. Sometimes it can be equal to the number of neutrons if you are talking of an atom, not an ion. Now I said here that the 15 is the atomic number of P3 minus, which is the number of protons. Are you following? In an atom, number of protons is usually equal to number of electrons. An atom, not an ion, an atom. Do you understand? So I said in an atom, number of protons is equal to number of electrons. But the P3 minus is an ion. Now, the minus 3 here tells us that this P3 is an anion, which simply means it's a negative ion. And it will need to accept 3 electrons. That's the meaning of this minus 3. The minus 3 simply means that it's looking for 3 electrons to accept from an electropositive element. Are you following? It's looking for an atom of an electropositive element, maybe sodium or maybe most likely aluminium, to give it this minus 3, to give it 3 electrons. When an atom accepts electron, it becomes a negative ion. When an atom donates electron, it becomes a positive ion. So since it is minus 3, a negative ion, it simply means that it will accept electron. So because it will accept electrons, the 3 electrons it will accept, you have to add it to this number of protons. Remember that this 15 is the number of protons and also number of electrons too, because protons and electrons must be equal in an atom, so an atom come electrically neutral. So it means it already has 15 electrons and it's going to accept 3 electrons. That is why it is minus 3. So the 15 plus the 3 electrons it needs to accept because of this minus 3 gives 18. So that is why your best answer is 18. Very simple. Question number 45 and the last for today. The atomic number of an atom would be equal to its mass number if the atomic number of an atom will be equal to its mass number if, let us split the two. Atomic number is number of protons, mass number is the number of protons and neutrons. So why or what do you think will make the atomic number of an element be equal to the number of protons? So what do you think will make the atomic number of an element to be equal to its mass number? If you look at the question critically, atomic number, number of protons, mass number, number of protons and neutrons. So that simply means that for the atomic number to be equal to the mass number, you have to remove this neutron. That's the only way. If you throw away the neutron, then atomic number will be equal to the mass number. So that will be protons, 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 protons. Do you understand? So if you remove the neutron, that's the only thing that will make the atomic number to be equal to the mass number. Are you following? So that's why the correct answer is as option C. Does not contain neutron. Does not contain neutron. So it is when the atom does not contain neutron, that is when the atomic number will be equal to the mass number. So the answer is Correct answer is option C. That kind of condition is seen in hydrogen. That's why you see hydrogen has 1, 1. Mass number of 1, atomic number of 1. Why? Because the hydrogen nucleus has no neutron. The hydrogen atom rather has no neutron. Do you understand? So hydrogen is mass number 1, atomic number 1. Why? The hydrogen atom has no neutron. I believe you understand this now. So students, with that, we've come to the end of today's section on WAEC past questions 2020 from number 41 to 45 with Mr. Chima from Prepclass Tutors. Now, if you look here, you see that there is a link here. We want you to click on this link. This link will link you to our WhatsApp group. So use that link to join our WhatsApp group. And when you do so, you will continue to be getting educational videos like this that you find interesting in what learning. So we'll call it a day today, and I'll be with you next time in chemistry from Prepclass Tutors. Bye and stay safe.